Hello, welcome back. It's great to have you here to do some revision on quadratic equations. We will be going through some examples together, so please get your pen and paper ready and work through these questions with me. So a quadratic equation is in the form y equal to ax squared plus bx plus c. The value of a gives us the shape of the quadratic curve. So we could have something with a curve like this. It's a happy curve, a sad curve, or a straight line. Now a straight line isn't a quadratic curve. This happens when a is 0. So if a is positive, the curve will be happy, and then if a is smaller than 0, then the curve will be a sad curve. However, if a equal to 0, it's going to be a linear equation. That means it's going to be a straight line. Plus c is also the y-intercept. So we could have a positive y-intercept or negative y-intercept. Similarly, we will have x-intercepts. Now, as you can see, this time we could have two x-intercepts. Very quickly, let's remind ourselves how to find the y-intercept. To find the y-intercept, you will need to let x equal to 0 find y. Similarly, if we want to find the x-intercepts, then we need to let y equal to 0 and solve for x. And then there are three different ways of solving quadratic equation. We can solve it by factorization, completing the square, or using quadratic formula. And when we solve for x, that is to look for the x-intercepts. There are also three cases. We could have two x-intercepts. And then that means this quadratic equation will have two solutions. We might have one x-intercept. That means we'll have one solution to the quadratic equation. And then finally, if I don't have any x-intercept, that means I will have no real solutions. Okay, now let's go through some examples. So the first example, we wanted to sketch y equal to x squared plus 5x take away 6. Now, if we look at the coefficient of x squared, so it's the a value, a equals to 1, which is greater than 0. So we know we will have a happy curve, and the negative 6 is our y-intercept. Now, to find the x-intercept, what we can do is to factorize it. To find the x-intercept, what we need to do is to set y equal to 0, and we have three ways of solving it. Let's go through the first one. If I set x squared plus 5x take away 6 equal to 0, by factorizing, what I need to do is to find two numbers that multiply together to give me negative 6, but add to give me 5. Here what I have is listing out the factors of negative 6. So I can make negative 6 by doing negative 2 times 3, negative 3 times 2, negative 6 times 1, or negative 1 times 6. Now if I look at the individual pair, I notice that negative 1 and 6 will give me 5. So what I do now is write down negative x and 6x. Now it doesn't matter where you write them, because you will get the same answer. Now what I want to do is to look at 6x and negative 6. The common factor of these two terms is 6. So I write 6 outside of the box. If I look at negative x and negative 6, I notice that the negative 1 will be my common factor. Therefore, we have factorized the quadratic equation. We have x take away 1, x plus 6 equal to 0. So that means x could be 1 or could be negative 6. Now we can sketch the curve. We have the xy intercept, and also we've got the right shape. Because we are sketching the curve, it doesn't really matter if it's not drawn to scale. Now let's look at the second example. Y equals to 2x squared plus 5x take away 3. Now this time, let's look at the coefficient of x squared. That is a value. A equals to 2, and it is a positive value, so it's going to be a happy curve. The y-intercept is going to be negative 3. To find the x-intercepts, what we need to do is to solve the equation when y equal to 0. We have 2x squared and the negative 3 in the box. 2 times negative 3 is negative 6. And then similar as before, I will write down all the combinations that will give me negative 6. And what I needed to do is to find the combination that add to give me 5. So negative 1 and 6 is the combination I'm looking for. Again, it doesn't matter which box you write it, we will get the same answer in the end. So let's first look at 2x squared and 6x. What is the common factor? The common factor is going to be 2x, so I'll write that outside of the box. Next, let's look at 2x squared and negative x. The common factor of this is going to be x. 6x and negative 3. The common factor is going to be 3. Finally, the common factor of negative x and negative 3 is negative 1. So we have successfully factorized the quadratic equation. It's going to be 2x take away 1 and x plus 3. So that tells me that x-intercept is going to be a half or negative 3. So now we can sketch the curve with x-y-intercepts labeled. Now we have done factorization. Let's sketch the curve using completing the square. And let's see if we are able to get the same answer. So with the first equation, what I need to do is to halve my b. So that means x plus 5 over 2 in the bracket squared. And then because if I were to expand the bracket, I'll have an extra term, 5 over 2 squared. And I don't want that, so I need to take away that by collecting the constant term. So that means simplifying this equation, we will have x plus 5 over 2 squared equals to 49 over 4. Now by solving this equation, what I can find, x equals to 1 or negative 6. As we can see, we've got the same answer as we were doing it using factorization. Completing the square actually tells us something more than just the x-intercept. If I look at this step here, what is the smallest value of x plus 5 over 2 squared occur? Now, we all know if we square something, the smallest value is going to be 0, and that happens when x equals to negative 5 over 2. So when x equals to negative 5 over 2, y is going to be 49 over 4. And then that actually gives me the minimum point of my curve. So the coordinates of the minimum point is going to be negative 5 over 2, negative 49 over 4. So now I'll be able to get a more accurate sketch. So now let's look at the second example. What happens if I have a 2 in front of my x squared? So the first thing you want to do is to factorize out 2 to make sure that we have something familiar so that we can complete the square. So by factorizing out 2, you will see 2x squared now becomes x squared. 5x now becomes 5 over 2x. If I just look at the bracket, now I have x squared plus 5 over 2x to complete the square. Similarly, I'm going to halve my b value, and then that will be 5 over 4. Take away 5 over 4 squared because that will be the extra term I have from expanding the brackets. By collecting the like term, I have a negative 25 over 16. So now what I need to do is to expand the bracket. So I will need to multiply x plus 5 over 2 squared by 2, and also negative 25 over 16 by 2. By further simplifying my equation, what I have here is 2 lots of x plus 5 over 4 squared, take away 49 over 8 equal to 0. Now by solving this equation, I will find that x is a half or negative 3. It is the same answer as before when we are solving it using factorization. By looking at this step, we'll be able to find the minimum point of my curve so that I will be able to have a better sketch. So the minimum value occurs when x equals to negative 5 over 4, and then the y value is going to be negative 49 over 8. So now I'll be able to go back to my curve and make improvement on my sketch. Finally, let's have a look at quadratic formula. In this example, a is 1, b is 5, and c is negative 6. Quadratic equation says by substituting these values into my quadratic formula, I will be able to find that the 2x-intercept is 1 and negative 6, which is the same as before. If we use quadratic formula to solve the second example, as you can see, a is 2, b is 5, and c is negative 3. By substituting those values back into our formula, we found out that x is a half or negative 3, and we can check that is the same as before. Well done for making through to the end, especially if you have done the questions yourself. Remember, maths isn't a spectator sport. To be better at maths, you have to keep practicing. Happy revising, and I'll see you in the next video.